All right, so let's take a look at another one. So we're going to start off by taking the Laplace transform of both sides here. So we have s squared y minus s times y at 0 minus y prime at 0 minus 2 times sy minus little y at 0 plus 2 times capital Y. Okay, and this is going to be equal to the Laplace transform of e to the negative t. So this is 1 over s minus that negative 1. Next up, we are going to fill in these pieces that we see. Okay, so we're plugging in the y value at 0, the derivative at 0 as well. So that's s squared y minus 1 minus 2 times s capital Y minus 0 plus 2 times y is equal to 1 over s plus 1. All right. Things that have y in them, we're going to keep on one side. Everything else will go over to the other side. So this is s squared y minus 2s capital Y plus 2 times y. And this is going to be equal to 1 over s plus 1 plus 1. Okay. And we can add these guys up together if we like. So this gives us s plus 2 over s plus 1. Let me do that a little bit more slowly. The common denominator is s plus 1. So we're just rewriting 1 as s plus 1 plus over s plus 1. So this gives us s plus 2 over s plus 1. Okay. Alrighty. Now we have y's all on the left side. Let's factor them out. That's s squared minus 2s plus 2 times y is equal to this s plus 2 over s plus 1. All right. Now I'm going to solve for y by dividing. So I have s plus 2 over s plus 1 times this s squared minus 2s plus 2. Okay, so it's probably time for us to consider whether we can factor s squared minus 2s plus 2. And a quick look at the discriminant at b squared minus 4ac, or negative 2 squared minus 4 times 1 times 2 tells us that this is irreducible because it's less than 0. And so that means for the partial fraction decomposition that we will have just 2 terms, a over s plus 1, and then bs plus c over this irreducible quadratic. All right, well, we may use a partial fraction calculator if you like to help ease this, but I'm going to do it out. So let's start by finding a. A is corresponds to a non-repeated linear term, so we can use the cover-up method. A here, we're going to be evaluating s plus 2 over s squared minus 2s plus 2, where that denominator is equal to 0. So we're going to be plugging in s equals negative 1. And this gives us negative 1 plus 2 over negative 1 squared minus 2 times negative 1 plus 2. Or 1 over 1 plus 2 plus 2. So 1/5. Alrighty. So next up, we need to kind of add these terms together in order to go forward. Okay, so our first term was 1/5 over s plus 1. When we find a common denominator, this is going to be 1/5 s squared minus 2s plus 2. Okay. In our other term, we have bs plus c all times s plus 1. We have this common denominator of s plus 1 times s squared minus 2s plus 2. And so therefore, we have that s plus 2 is 1/5 s squared minus 2s plus 2 plus bs squared plus cs plus bs plus c. Okay. Now, we can either plug in different values of s. So for example, we could plug in s equals 0, s equals 1, or another common strategy that's often helpful is regrouping based off of powers. So I'm going to do that here just to show it off. So this is going to be 1/5 plus b times s squared on the right side. In terms of s terms, we have negative 2/5 from the first piece plus c plus b times s. And then in terms of constants, we have 2/5 plus c is going to be equal to s plus 2. All right, so that means that 0 equals 1/5 plus b from the s squared terms. There are none on the left, and there's 1/5 plus b on the right. So b is negative 1/5. From the constant terms, we see that 2 is equal to 2/5 plus c, or 10/5 equals 2/5 plus c. So that means that c is 8/5. Alrighty, okay, and now we have our decomposition. We know that y is going to be equal to, okay, our a value that we found was 1/5, 1 over s plus 1. We had, let's go back up here, bs plus c is over s squared minus 2s plus 2. So we have negative 1/5 s over s squared minus 2s plus 2 plus 8/5. Got him. Alrighty, and now we want to look at for inverse Laplace transforms. So this, because we have this irreducible quadratic, again, we're going to expect to see we are going to complete the square, taking half of this coefficient of s. So the coefficient of s was equal to negative 2. So half of that gives us negative 1. When we calculate s minus 1 squared, this is s squared minus 2s plus 1. So we've added in an extra 1. We're just going to subtract that away. So this is 2 minus 1. And then the kind of format that that our formula needed was that we had S minus this A value. So let's just write out the pieces that we see here. So 2 minus 1 gives us 1. We had A equals 1, and we also have that B equals 1. So this one was our A, and this guy was our B squared. All right, so we're just gonna like make this have that correct format. So we're gonna write -1/5 S minus 1. If we were to multiply this out, notice -1/5 times -1 gives us plus a fifth. So we're just going to subtract off an extra fifth so we don't change the value of our numerator. Okay, so all told, we have 1/5, 1 over S plus 1, plus -1/5 S minus 1 over S minus 1 squared plus 1 squared. And then sort of off separately, we have 7/5 times 1 over S minus 1 squared plus 1 squared. So this is our y. Now it's time to take inverse Laplace transforms. Okay. So the inverse Laplace transform of big Y is little y. The first term, 1/5, 1 over S plus 1 gives us 1/5 e to the negative t. Then we have -1/5 e to the t cosine of t. Our a value of 1 goes up into the exponential function. The b value of 1 goes inside of the cosine. And then this is going to be plus 7/5 e to the t sine of t. All right, and one thing I'd like you to notice here. So look at the format of our solution here. We have solved it. I mean, it took a little while, but we solved this non-homogeneous DE with initial value conditions. And our answer gives us the, we get to our answer right away. We're not like finding a homogeneous solution, guessing a particular solution, matching initial conditions. It's all at once. Great.